Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to explain the chapter Carbon and its compound for the class 10, and that is according to CBSE syllabus. Now part 13, that is what is saturated hydrocarbon. Now I am going to explain the saturated hydrocarbon under the chapter Carbon and its compound. What is meant by saturated hydrocarbon? Saturated means here you know carbon has 4 valency. 4 valency of carbon. See here, 4 valency of carbon is satisfied by any atom, simple any atom, hydrogen, chlorine, bromine, any atom, and that is called saturated, or by any group of atoms also. Any atom or group of atoms, if it is satisfied, then it is called saturated hydrocarbon. Are you clear? Saturated hydrocarbon means 4 valency of carbon satisfied by any atom or group of atoms. And here that is saturated hydrocarbon, which is also called parent hydrocarbon. Why it is parent hydrocarbon? Because here it is the main from which all the different organic compounds are derived. All the carbon compounds are derived. That is why it is called parent hydrocarbon. That is, example is alkane. In alkane is also called, alkane is called parent hydrocarbon. In saturated hydrocarbon, the example is alkane, that is called parent hydrocarbon, and that contains single bond. Since it is one saturated example of saturated hydrocarbon, it contains single bond. If instead of hydrogen alkane, you can take haloalkane also, that is also saturated hydrocarbon. Methyl alcohol, that is also saturated hydrocarbon. That means here alkane is one example of saturated hydrocarbon. It is also called paraffins. Why it is called paraffin? Paraffins mean inactive. Generally the carbon that compounds, that is alkane, is one very inactive one. It is never active. That is why it is called inert alkane, or you can call paraffins. What is mean paraffins? Inactive. Why it is paraffins? Why it is inactive? Because due to single bond. I told in nature of covalent bond, if one covalent bond, that is very active. If two covalent bond, out of two, one is active, other one is out of two bonds. If it contains two bonds, that is active. That means if single bond, that is inactive. If double and triple bond, that is active. Double bond, that is the example of unsaturated hydrocarbon. After this I will come to what is meant by unsaturated hydrocarbon. And alkyne, the triple bond alkyne also called unsaturated hydrocarbon. Unsaturated hydrocarbon example what? Alkene and alkyne. Later I will discuss. Now here I am going to explain, I am going to discuss about alkane. Alkane is one example of saturated hydrocarbon, and that is general formula. Then what is general formula? Here CnH2n plus 2. Here that IUPAC, International Union of Purified Applied Chemistry, that IUPAC, that word exists for the whole world. For the whole world the name remains same. That is why it is IUPAC name. And alkane, what is the formula? And the general formula, that is CnH2n plus 2, where what is N? N it indicates the numeral. That means if N equal to 1, and here H2n means 2 into 1 plus 2. That means 4. C1H4, first compound. First that alkane, that is the one that is alkane is methane. What is that one? Methane. C and H2n plus 2. C1 Cn means let 1. CH2n means 2 into 1 plus 2. That means CH4. Here it is CH4 means that is our methane. 1 carbon methane, 2 carbon ethane, 3 carbon propane, 4 carbon butane, 5 carbon pentane, 6 carbon hexane, 7 carbon heptane, 8 carbon octane, 9 carbon nonane, 10 carbon decane. Like this you will remember up to decane. Now see, if N equal to 2, then what is the formula? C2H6. That is called ethane. And how can you write the structure? Actually, if you write in condensed form, that is formula. If you write in expand form, see here, CH3. When you will write that formula, structure, then formula only put this one, CnH2n plus 2. And structure you write in such a way that carbon valency should satisfy. Carbon valency 4 should be satisfied. See here, S3 means 3, 1, 4. Here see, S3 means 3, hydrogen 1, 3 hydrogen 3, this one. So for carbon you count this and 3, for carbon count this bond and 3. So here it is satisfied. When the structure whatever structure you see and count whether the 4 valency of carbon satisfied or not. If satisfied, then structure is okay. If not satisfied, then structure is wrong. Then we will proceed to if N equal to 3. If N equal to 3, count here. N equal to 3 means 3 into 2, 6 plus 2. What is the formula? C3H8. From propane you will see that is N equal to 3, that is propane. You will see next here. After the ethane, we will see carbon 3. Carbon 3 means N equal to 3. If N equal to 3, if you put, then what is this one? C3H8. Because the formula is here CnH2n plus 2. Then what happened here? Then you see here what is propane. Propane means 3 carbon. See 3 carbon and middle is CH2. Why not CH3? Because here you can observe that carbon is not satisfied if you will put 3. If the carbon valency become to 5. So here see 1, 2, 3, 4. Hydrogen 2 means 2. 2, 1, 3, 1, 4. So satisfied. Here also satisfied propane. Similarly butane. What is the formula? N equal to 4. C4H10. CH3, CH2, CH2, CH3. That means you can see here, first is CH3, last is CH3, in middle only CH2, CH2. Here CH3, CH2, CH2, CH3, butane. Then C5H12. Then here first is CH3 and last is CH3, the 2 CH3 and now it is remaining, 3 CH2 remaining, CH2, 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 pentane. If N equal to 6, C6H14, then here first CH3, last CH3 and what is remaining 4 times CH2, 1, 2, 3, 4, hexane. Then come to heptane, that first CH3, last CH3 and carbon number 7, then N equal to 7. So NC7H16, that is heptane. Here see, first and last CH3, sorry, it's not CH3, CH2. So first CH3, last CH3, then what is remaining? 5 times, 5, 6, 7, 1, 2, 3, 4, 5. Okay, correct, heptane. Then octane 8, C8H18. See here, first and last CH3 and middle what to be? 6 times. 1, 2, 3, 4, 5, 6. Okay, correct. Here it is C8H18, C9H20 nonane, N equal to 9. First and last CH3, 2 CH3 and remaining 7 times CH2. 1, 2, 3, 4, 5, 6, 7. Correct. 7 and 8, the last one 9. So N equal to 9, the carbon number 9. So it is H20, so nonane. Then come to C10H22. Then here first CH3, last CH3 and middle 1, 2, 3, 4, 5, 6, 7. 7 here 1, 2, 3, 4, 5, 6, 7, 8. Correct. 8, this 9, last 10. Like this remember. Like this pentane asking means first CH3 put, last CH3 put, middle how many times? 3 times CH2 will put. Pentane 1, 2, 3. This is the alkane. That means what is the general formula and structure and YP selenium clear. Then we will come to the dot structure of alkane. How can you write a dot structure of alkane? And next you will see dot structure of alkane. Now it is continued, that is saturated hydrocarbon 13A. Now here we will see electron dot structure of alkane. You know alkane contains single bond. That is what is called saturated hydrocarbon. Alkane is also called paraffins. Alkane always contains single bond and it is the parent hydrocarbon also. Now how can I write electron dot structure of alkane? Simple, you see formula of methane, you know formula of methane is CH4 having CH, 4CH single bond, you know it. Then you think yourself, how can you write the dot structure of methane? Then how can you see the covalent bond form in methane? Now atomic number is 6, so electronic configuration 2, 4. 4 electron remain outer shell. Yes, the dot one is for carbon and the cross one is for hydrogen. The cross electron for hydrogen, dot electron for carbon. You know 4 electrons in outer shells of carbon. Similarly, hydrogen contain 1 because atom number is 1, and here 1 represent the electron. That means 1. Here see 1 electron. Here 4 electron. That is for 4 hydrogen atoms. Now see here carbon 1 dot electron and it is cross electron. So bond is formed between carbon and hydrogen. Similarly carbon and hydrogen, and here also carbon and hydrogen bond form. And you know the sharing of electron takes place between carbon and hydrogen. There is a covalent bond. Sharing electron takes place. Similarly, how many? 1, 2, 3, 4. 4 pair of sharing electron takes place between carbon and hydrogen. So see carbon and hydrogen, and this is the bond. What is that bond? Covalent bond. So here 4 times CH bond form. Here you can't put any double bond, double sign or arrow mark because all are indicating any bond. That is why bracket CH. And here if you come to ethane, what is ethane? C2H6. It is the structure of ethane. How many? 1, 2, 3. 1, 2, 3. 6 CH bond form. And one is C and C bond. That means C and C one bond, and 3 CH and 3 CH. Totally how many? 6 CH bond form. Now here what happened about our ethane structure. Ethane CC 2C I put, and 1 electron here dot electron for carbon. So 4 dot electron for carbon. Here also 4 dot electron for carbon. And here the cross one for hydrogen. So 1 sharing takes place here. 1, 2, 3 sharing on the right side and 3 sharing on your left side. Then totally how many sharing takes place here? Between carbon and hydrogen, 6 sharing takes place. 6 pair of electron sharing. That means it forms a covalent bond between what? Carbon and hydrogen. And what happened between carbon and carbon? See, carbon and carbon also 1 sharing takes place. That is between carbon and carbon. So here 1 covalent bond takes place. And here how many? 6 CH. So here 6 CH bond form and 1 C bond form. Now here this is the structure. Whether that inert gas configuration satisfied or not in between 2. See, check it. Hydrogen 2 electron, that is it satisfied the inert gas of helium. It never satisfied octet, but exception case it only satisfied the helium inert gas configuration. But when come to carbon 2 to 4 to 6 to 8, that means 8 electron octet rule. Octet that 8 electrons in outermost shell and 2 electrons already there. That means 2 8 means 10. That is inert gas configuration of neon satisfied. Every element has a tendency to attain inert gas configuration by sharing electron or by losing and gaining electron. Here by sharing electron, here carbon satisfied octet, that inert gas configuration of neon, and octet rule of that means 8 electron in the outermost shell. Here also same, hydrogen satisfy the inert gas configuration of helium, and carbon satisfy here octet. See, count here 4 electron pair in surrounding to carbon, here also 4, here also 4. That means it satisfies the carbon octet rule, and it satisfies the inert gas configuration of neon. That is why both the structure fully correct. And here how many? 6 CH bond and 1 CC bond, and in simply here how many CH bond? 4 CH bond. 1, 2, 3, 4. I think it is clear to you. Already I have explained in covalent molecule, I think in previous part. I hope it is clear. In next coming part 13B in saturated hydrocarbon, I will continue the isomerism of generally butane, pentane and hexane. Hope you will subscribe my channel BL Das Short and Sweet in Chemistry, and thanks for watching my video. Thanks again to all.